Hi everyone. Today we are going to see some of the basic laws in circuit theory. In that, we are going to see the Kirchhoffs law. The Kirchhoffs law, we have two different types. The one is Kirchhoff's current law, another one is Kirchhoff's voltage law. The Kirchhoff's current law, KCL, is based on the law of conservation of charges, and Kirchhoff's voltage law, KVL, is based on the principle of conservation of energy. Now we are going to see Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of all voltages around a closed path is zero. Mathematically, summation m is equal to 1 to m, Vm is equal to 0, where m is the number of voltages in the loop and Vm is the mth voltage. We can define KVL in another form, which is sum of the voltage drops is equal to sum of voltage rises. This can be proved from the circuit given here, and V1 is the voltage source, V4 is another voltage source, and V2, V3 and V4 are the resistive elements. So before applying KVL, we are considering a current of I which is flowing through the circuit in the direction given here. So according to KVL, the voltage around a closed path is equal to 0. So before writing the voltages of different elements, we can have the sign convention. So here the current I is entering into a minus sign, so that you can write minus V1 here entering into positive, so plus V2, again plus V3, here it is entering into a negative, therefore minus V4, then here positive, so plus V5. So this equation becomes minus V1 plus V2 plus V3 minus V4 plus V5 is equal to 0. So that rearranging this equation, we can get V2 plus V3 plus V5 is equal to V1 plus V4. This V1 plus V4 is the voltage rises, and V2 plus V3 plus V5 is the voltage drops. Therefore, KVL can be alternatively defined as sum of the voltage rises must be equal to sum of the voltage drops. And combining different voltage sources connected in series is one of the applications of Kirchhoff's voltage law. So here in the circuit given, we have the voltages V1, V2 and V3, and in order to combine these three series connected voltage sources, we are going to use a Kirchhoff's voltage law. So according to Kirchhoff's voltage law, we know that the sum of the voltages around a closed path is equal to 0. Therefore, consider a closed path current I, direction given here. Therefore, we are having the equation minus VAB plus V1 plus V2 minus V3 is equal to 0. So rearranging this, we can have VAB is equal to V1 plus V2 minus V3. Therefore, this circuit of three different voltage sources connected in series can be converted into a single voltage source of the equivalent value V1 plus V2 minus V3. Let us see an example for the Kirchhoff's voltage law. Example 1. For the circuit in figure, find voltages V1 and V2. So before finding out voltage V1 and V2, consider a current I which is flowing in the clockwise direction. So by applying Kirchhoff's voltage law, we can write the equation as minus 10 plus V1 minus 8 and minus V2 equal to 0. And by applying Ohm's law, we can have V1 is equal to 4 into I, and V2 is equal to 2 into minus I, which gives you 2 into minus 2 into I, which means why we put minus here is the current I is entering here in minus, right? By substituting V1 and V2 in the equation, we can have minus 10 plus 4I minus 8 and minus V2 minus into minus plus, so that plus 2I, which gives you 0. And rearranging this equation, we'll get 6I is equal to 18 and I is equal to 3 ampere. Therefore, a current of 3 ampere is flowing into the circuit. Now we need to find out the voltages V1 and V2. So we know that V1 is equal to 4 into I, which gives you 12 volt, and V2 is minus 2 into I, which gives you minus 6. So we can also verify the Kirchhoff's voltage law by applying these voltages in the loop. Therefore, it gives you minus 10 plus V1, V1 is 12 here, minus 8, and minus V2, minus into minus, again it gives you plus, equal to 0. So minus 18 and plus 18. Therefore, we found out that V1 is equal to 12 volt and V2 is equal to minus 6 volt. Example number 2, for the circuit in figure, find voltages Vx and V0. Here, this 2 Vx is the dependent voltage source, which depends on the Vx, which is the voltage across 10 ohm resistor. So before applying KVL, let us consider a current I, which is flowing through the circuit in the clockwise direction. Therefore, by applying KVL, we can write the equation as minus 35 plus Vx plus 2Vx minus V0 is equal to 0. Then, by applying Ohm's law, Vx is equal to 10 into I, and V0 is equal to minus 5 into I. Substitute these values into the equation. We can have minus 35 plus 10I plus 20I minus into minus plus 5I equal to 0. Therefore, 35I is equal to 35 and I becomes 1 ampere. Therefore, a current of 1 ampere is flowing through the circuit in the given direction. And we need to find out here Vx and V0. We know that Vx is equal to 10 into I, therefore Vx of 10 volt, and V0 is equal to minus 5 into I, therefore it is minus 5 volt. Again, we can cross verify this by applying these values. Plus 35 plus Vx, Vx is 10 plus 2Vx gives you 20, then minus V0, again minus into minus plus 5, which gives you 0. That's all about Kirchhoff's voltage law. And if you have any queries, you can mail it to kgcenterforlearning@gmail.com, or you can post your queries in the chat box. Thank you.